Hello everyone, and in this tutorial we're going to create like a school of fishes just sort of swimming around in a circle. So this isn't very complicated. We're going to use like particles to do the basic stuff, and then we'll use trails to sort of generate the fishes. Okay, so to get started, I'm going to take a circle. So I'll just copy the circle from here. So I'll just do like Control C, Control V, and that's the circle. So the first thing I want to do is I just want to distort it, and you can use a mountain. So if you use like a mountain saw, you can distort this, but it'll distort vertically. Okay, because all the normals are sort of pointing upwards. So just distort it vertically. What I'll do is I'm going to take the amplitude low, make it like 0.05, and also lower the element size. But what I also want is, but if you look at it from top, it's still a circle. Okay, so I want it to distort outwards as well. So what I'm going to do is, in the beginning, like before we apply the mountain, we're going to apply two mountains. I'm going to take an orientation along curve, and it distorts in the direction of the normal. So we will generate normals that point outwards. So I'll just click here, and I'll come to additional rotations. Yeah, and take the yaw and just make it 90, so it points outwards. And now if you look at the mountain, it sort of distorts its outwards, but the problem is that from the front it's still the same. So what I can do is, after I've applied this mountain, I'm going to delete the normals. So I'll just do like attribute delete, and I'll get rid of the normals, and then apply the same mountain again, and that will apply it in the y-axis. So you'll get, so see, so now this is applying it in the y-axis, and this takes care of the x and z. So it's not needed, but yeah, it'll make sure that all our emissions don't happen from like a clean circle. So this is done. Now let's take a pop network, and let me just come to frame 1. Okay, so one of the first things I'm going to do is I'm just going to give it some sub-steps. Okay, so I'll take about like 5 sub-steps, so we get like a fairly smooth motion. Okay, so I'm going to jump in, and we have our source. So I'm going to turn off guides. So what I want is, I want an impulse count of 2. Okay, so every frame it will emit like 2 particles, and I want it to emit for about 20 frames. So I'll do like $FF less than 20. So you'll get like particle emission happening for 20 frames. Okay, so the first thing we want to do is we just want this to go around, in a circle. So what you do is you take a pop axis force. Okay, so just take a pop axis force, and you'll end up with this. Okay, like it generates a circle that is the area within which it will sort of spin around. So what I'm going to do is I'm going to make it slightly bigger, and I'm going to reduce the height. Okay, then we just need to control the speed. Okay, so I'm going to take the orbit and make it about 6. And the suction speed will keep to 1. So the suction speed will sort of pull it inwards, and the orbit will make it go around in a circle. If we don't have the suction speed, it'll just, everything will just spin outwards like that. Okay, so it's a good way to make a galaxy, but we don't want a galaxy. The suction speed will sort of pull it inward, so it doesn't, like fly off immediately. But we will also have to apply like a drag to make sure that it doesn't fly off. Okay, so the second thing is just take a drag. So take a pop drag, and I'm going to keep this fairly high. So I'll keep it around 20. And what this will do is it'll just make sure that, they just kind of stay in place like that. Okay, but now we need to add some variation to this. So let's take the pop axis force, and we'll come to use vex expressions, and just click here and do pass through. So it'll just add in all of these values. I just want to modify the orbit speed. So we'll just work with that. I want to multiply my expression with this value. Okay, so I'll just do a multiply equal to. And what I want is, I'm going to randomize the force based on the particle ID. Okay, so I'll take a fit01, and we want to do a random based on @ID. We'll add a seed value. Okay, so you can add any number that you want. And then I'll go between 0.2 and 1. Okay, and what this should do is, it'll give me a bit more variation on the whole thing. Okay, another thing I want to do is I just want to come here to the behavior and we'll turn off treat as wind. It'll make it go a little bit faster. See, so now they're kind of more or less stable. So not a very complicated thing. The other thing I also want is, let's just take the life. Yeah, it's about 100, which is fine. Like, you want it to stick around a long time because we want them to be like, you don't want them to randomly start disappearing. I can also modify the drag. So I'll just take the same thing here from here, so I'll just copy this, do Control C, and I'll just, I'll add in something. So because this is called something, right? So this is called air. So what's the parameter name is what you need to type there. But if you click here, there's usually a formula that you can use. So it'll just type it in for you. So you can just delete the rest. We don't need that. And I'm just going to, put in this much. Yeah. And so this will add a little more drag to the whole thing, like a varied drag. I think a little higher would be good. Okay, so let's do like 0.8 and we can modify the ID, the seed value. Yeah, I think this is nice. Okay, now the one thing I can do is if I want it to remain within a certain area, I can take a pop limit. Okay, so just take a pop limit and I'll keep the size to about 0.4. Okay, so make it go here and keep the, no, don't take a pop limit, take a pop soft limit. Okay, so if you type in pop soft limit, you'll get, yeah. Okay, this will allow you to, like, with the pop limit, the issue is that it's just a box. With the pop soft limit, you get the ability for a sphere. Okay, so a sphere is what we want. Okay, so just change this to a sphere and then make it 0.4. And then you can also just sort of increase the damping and the force a little bit. So this will sort of, like, if it exceeds beyond that, it'll just stick to that border line and it won't go beyond that. See, so now you have like a fixed zone within which it is kind of spinning, okay, which is nice. So I think, like, if you start the simulation from somewhere around, like, or if you, render it from somewhere around 120, you get a pretty decent, like, spinning motion that more or less remains, the same. Okay, so this is done. That's our simulation. So nothing overly complex. Okay, now let's make the trails, because what the idea is, I'm not going to put actual geometry on it. We're going to build the geometry, because like putting geometry on it sort of slows it down. So it's better, because how many particles do we have? We have about 190. But if you have a lot of them, it'll start to slow down. So we're just going to generate trails and then build geometry using those trails. So what you want is just take pop trails, okay, or just type in like trails. So, okay, it's called particle trail. And yeah, let's just start from 0 for now. So plug this in and this will automatically start generating trails, but we want them to be long. Okay, so the first thing you want to do is come to the shape and we want it to be about, the frame duration is how long the trail will be. Okay, so we want it for about like 10 frames, but we also want like more segments in there, because right now it's just like each line is just like 2 points. So what you want to do is take the substeps and make it around 20. Okay, see, so now it, curls like that. If you want them to be like slightly shorter, what you can do is you can take the length end and you can make it, shorter from the beginning. So this is sort of like a carve, plain and simple. And we'll also add some positional noise to this. Okay, like not that much. So let's just come down here. So I'll keep this to 0.03 and the element size to 0.7. Okay, see, so there you go. So what you have now is you have like these squiggly lines that kind of spin around, which looks nice. The only thing that will happen is like the lines on the inside will be smaller and the lines on the outside will be longer. So just imagine like the bigger fishes swim on the outside and the smaller ones are on the inside. Okay, this is not like a perfect solution. Okay, so this is good. Now what I want to do is just give it some look. Okay, so I can just come to the color and I can say color along length, and I'll set it to the one that I like the most, which is two-tone. So I like using that. Okay, and I'll just kind of spread it out a bit like this. So yeah, there you go. So you have like, fishes. Okay, so now we need to turn this into fishes. Okay, so what I'm going to do is we want to make the main body and the tail and the fins. Okay, so I'll start off with the main body. So just take a sweep and I'm going to set this to round tube. Turn off this, there you go. And we lower the radius and I'll set this to like, I'll set it to grid, okay, which is fine. And I'll do apply scale along curve and we'll shape it up. So I'll take a B-spline for both and I'll take this small and take it like that and do this. So there you go. So you get like, tiny fishes swimming. See, so the outer ones get a little too long. Okay. But what we can do is we can try to just like, you can't, shape it up in any particular ways, but I'll just lower the length on the outside. Okay, now let's add the tail. Okay, so what I'll do is I'm going to take another sweep and I will take a carve. So just take a carve node and I'm going to cut it from the second U. Yeah. So this is, like if I look at it here, sorry, if I look at it from there, hold on. Yeah, we're cutting it towards the back. Okay, so this is fine. So now plug in the sweep here and I'll set this to ribbon. So just take this, the surface shape and set it to ribbon. And we don't want any columns and make it really small. Okay, and then we want to do two things. Firstly, we want to come into construction and set the target up vector to Y so that it doesn't flip around. Like if you keep it like this, you'll see like it, see it sort of like flips all the time. So what you can do is set it to Y and that will make it more or less constant. Okay. And then I can just come in here and take the shape and we'll again just set it to B-spline. Sorry, other way around. Yeah, there you go. Okay, so you can just take this and adjust it. So that gives you like, a tail. So if I like merge these two things together, what you can also try, which I didn't try at that point of time, is we can probably put another limit on the inside and it has that option to sort of invert the limit. So then you won't have particles going this far deep. Okay. Or just put a sphere in there for collision, that might work as well. Okay. And then I also want to create like fins. So I'm just going to take this and duplicate it and I'll plug this in. So this is the tail and these are the fins and this is the body. And for the fins, what I'll do is I'll just take this carve, okay, and I can just take, this to be here and this will come down and make it bigger. See, okay. Maybe let's bypass the carve. Yeah, there you go. See, so that's not bad. Okay. You can just define like the size of this. Yeah, like, keep it where you want it. Yeah, there you go. And then what you can do is you can also give them some color. Like if you want the fins and this to have a separate color, we can just give it some color. So let's say we want the fins to be like red. Like let's disconnect these two. We'll merge the fins and the tail and give them a single color. Yeah, there you go. See. So let's just finally try that one thing, which is I'm going to take the pop soft limit and duplicate it, do Control-C, Control-V, and you can invert it and make it like really small. So what should happen is they won't go beyond this point. So what I can do is let's make it slightly bigger. So you'll have like a, like if you want to create like a roughly uniform size to all of it, see, there you go. They're kind of bouncing off it, which is fine. Okay. So some of them are still going inside because there's a little bit of damping, but most of them kind of remain, out there, which is good. So if we come out here, see, so now they won't go like, you'll have like a hollow part on the inside. Like, most of them won't go too far in. But there you go. You have fishes. All right. So that's pretty much it.